Tangents and normals. In this section, we are going to learn the definitions of tangents and normals and how to find their slopes and their equations. Let us consider this graph y equal to f of x. Let us draw a tangent to this curve at the point A. A tangent to a curve is a line that just touches the curve at one point. Let us see the next graph, y equal to f of x. It is a sine graph. We will draw a tangent at the point A, just touching the curve at A. But if you see, this tangent line intersects the curve at another point B. Therefore, we can say that a tangent line at a point A is the limit of the secant lines as P approaches A. Let us take P point here. AP is a secant. As P approaches A, the secant line becomes the tangent. Or we may take P on the other side also. So we can have a secant here. And as P approaches A, the secant line becomes the tangent. Therefore, limit h tending to 0 of f of x plus h minus f of x divided by x plus h minus x, which is h. This is the slope of the tangent, which we learnt in class 11 using the first principle formula. The P point can approach A point from both the sides. That's why we say that LHD must be equal to RHD. Then only slope of the tangent exists at that point. That means we can draw a tangent at that point. Therefore, the derivative of the function at this point A is the slope of the tangent line. So, the curve and the tangent share the same slope or the gradient at the point of contact. Now, see the third figure, y equal to f of x. This is the graph of absolute value function. Let us try to draw a tangent at the origin to this curve. It looks as though x-axis is a tangent to the curve. We can draw infinitely many lines through the origin, but they are not tangents. Here, as x approaches 0, LHD is not equal to RHD. On the right side, it becomes y equal to x. On the left side, it becomes y equal to minus x. Therefore, slope on this side is plus 1 and slope for this curve is minus 1. So, as we approach 0, the slopes, they don't approach to the same value. Therefore, we cannot draw a tangent to this curve at x equal to 0. Therefore, we can now say that f of x should be smooth enough in the neighborhood of that point A to have a tangent line. It should be a smooth curve like this to have a tangent at a point. So, here this turning point is not smooth. Similarly, this curve, we cannot draw a tangent at this point. Now, we will see how to find the slope of a tangent under different conditions. In this figure, let y equal to f of x be a straight line which makes angle theta with the positive direction of x-axis. Then slope of the tangent is equal to tan theta. What is the slope of a tangent? How fast y coordinate changes as x coordinate changes, which is dy by dx, or we may denote this as f dash of x. If 2 points on this line are given, say, let us take this point as x1, y1 and this point as x2, y2. We can find the slope of the tangent in this case also. Slope of the tangent dy by dx will be y2 minus y1 upon x2 minus x1. So, for linear function, that is for a straight line, the slope at any point on this line will be the same. It has a constant slope. Now, see this curve y equal to f of x, which is a parabola. Here, the slope keeps changing. So, in this curve, rate of change of y with respect to x, that is dy by dx, is different at different points. It keeps changing. Then how do we find the slope of a tangent at a particular point? So given the function y equal to f of x of the curve, we find the derivative dy by dx, which is f dash of x. For example, A is a point given as 2, 3 say. So we will substitute 2, 3. We find f dash of 2. We get the slope of this particular tangent which is drawn to the curve at the point A, which is 2, 3. If angle made by the tangent with the positive direction of x-axis is given, say, then we use tan theta formula to find the slope. And if we know 2 points on the tangent, say, then we can find the slope using this formula. And if the point of contact and the equation of the curve are known, say, then we can use this formula to find the slope of the tangent drawn to the curve at that point. Now we will see how to find the equations of tangent and normal. Let us consider the given curve y equal to f of x, and A is the given point. Let us take the point of contact as x0, y0, and this is the tangent to the curve drawn at the point A. So given the equation of the curve y equal to f of x, we will differentiate and find dy by dx, and we can find dy by dx at the given point x0, y0, which is f dash of x0. That becomes the slope of the tangent. Now we know one point A on the tangent and we know the slope of the tangent. We can use point slope form and write the equation of the tangent. It is y minus y0 equal to m times x minus x0. Now let us draw a normal line to this curve at the same point of contact A. A normal is a line which is perpendicular to the tangent through the same point of contact A. These two are perpendicular to each other. So if we know one slope, we can find the other slope using the condition m1 into m2 equal to minus 1. This is the perpendicularity condition for two lines in terms of their slopes. Therefore, slope of normal will be minus 1 upon m, where m is the slope of the tangent. Now we know the slope of the normal and we know it passes through x0, y0. We can use point slope form to write the equation of the normal. Y minus y0 equal to minus 1 upon m times x minus x0. So remember, to find the equation of a tangent and normal, we need the point of contact and the slope. You should know the following points. The first one, slope of x-axis is 0. Second point, slope of any line parallel to x-axis is also 0. Third point, slope of y-axis is not defined. Fourth point, slope of a line parallel to y-axis is also not defined. Let A be the point of contact x0, y0. We will draw a tangent at this point of contact and it is parallel to x-axis. Equation of this tangent will be y equal to some constant. That constant is y0. So equation of a tangent line at x0, y0 which is parallel to x-axis will be y equal to y0. Let us take point A, the point of contact as x0, y0. We will draw a tangent to this curve at A which is parallel to y-axis. Equation of this tangent, as this is parallel to y-axis, equation will be of the form x is equal to some constant. That constant here is x0, which is the x-coordinate of that point. Therefore, equation of a tangent line through the point x0, y0 parallel to y-axis will be x equal to x0. Now let's do exercise 6.3. The first 6 questions of this exercise are finding the slopes of tangent and normal. Let us do the first question. Find the slope of the tangent to the curve y equal to 3x power 4 minus 4x at x equal to 4. We know that dy by dx is the slope of the tangent at any general point x comma y. So the derivative is 12x cube minus 4. But we need the slope of the tangent drawn to the curve at x equal to 4. Let us plug in this value 4. 12 times 4 cube minus 4. 12 times 64 minus 4. 768 minus 4. The answer is 764. Second question. Find the slope of the tangent to the curve y equal to x minus 1 upon x minus 2, x not equal to 2 at x equal to 10. Let us differentiate to find dy by dx. We will apply quotient rule. Differentiation of x minus 1 is 1 times the denominator minus x minus 1 times 1 divided by x minus 2 the whole square. X and x are getting cancelled. Minus 2 plus 1 is minus 1 upon x minus 2 the whole square. Now we need the slope of the tangent drawn to the curve at x equal to 10. Minus 1 upon 10 minus 2, 8 square, minus 1 upon 64. Third question. Find the slope of the tangent to the curve y equal to x cube minus x plus 1 at the point whose x coordinate is 2. dy by dx is 3x square minus 1 and we will find dy by dx at x equal to 2. 3 times 4 minus 1, 12 minus 1 is 11. Question number 4. Find the slope of the tangent to the curve y equal to x cube minus 3x plus 2 at the point whose x coordinate is 3. It is the same type of question. dy by dx, derivative of x cube is 3x square minus 3 times 1. We will find dy by dx at x equal to 3. 3 times 9 minus 3. 27 minus 3, which is 24. If the slope is positive, that means the tangent makes an acute angle with the positive direction of x-axis. And if it is negative, that means the tangent makes an obtuse angle with the positive direction of x-axis. Fifth question. Find the slope of the normal to the curve x equal to a cos cube theta, y equal to a sin cube theta at theta equal to pi by 4. In this question, we have to find the slope of the normal. Underline the word normal in the question. And these are parametric equations. We know how to find dy by dx for parametric equations. We will first find dx by d theta, dy by d theta and divide. A is a constant. We will apply chain rule. Power has to be differentiated first and then the base cos theta. Differentiation of the power is 3 cos square theta times derivative of cos theta is minus sin theta. Now we will find dy by d theta. A is a constant. Here also we have to apply chain rule. Power has to be differentiated first, which is 3 sin square theta times derivative of the base sin theta is cos theta. Therefore, dy by dx, which is slope of the tangent, we will divide dy by d theta divided by dx by d theta. 3a sin square theta times cos theta divided by 3a cos square theta times minus sin theta. Be careful, you have to write dy by d theta in the numerator. The answer is minus tan theta. But we need to find dy by dx when theta is pi by 4. It is minus tan pi by 4. It is minus 1. And this is slope of the tangent. We have to find the slope of the normal. If you know one slope, easily we can write the perpendicular slope. Slope of the normal is negative of its reciprocal, which is plus 1. That is, using the result m1 into m2 is minus 1. Question 6. Find the slope of the normal to the curve x equal to 1 minus a sin theta, y equal to b cos square theta at theta equal to pi by 2. In this question also we have to find the slope of the normal. We have parametric equations. We will find dx by d theta and dy by d theta and divide. Derivative of 1 is 0, minus a times derivative of sin theta is cos theta. Dy by d theta is, b is a constant. We will apply chain rule. Power has to be differentiated first, keeping the base same. Times, now base has to be differentiated. Differential of cos theta is minus sin theta. We will find dy by dx, which is dy by d theta upon dx by d theta. Be careful, we have to write dy by d theta in the numerator, minus 2b cos theta sin theta over minus a cos theta. We get 2b by a sin theta. Value of theta is given. Therefore, dy by dx, which is slope of the tangent, at theta equal to pi by 2 is 2b by a sin pi by 2. Sin pi by 2 is 1. Slope of the tangent is 2b by a, but we need to find slope of the normal. Is equal to, change the sign and write the reciprocal. That is, using the result m1 into m2 equal to minus 1. In the next 3 questions, we are going to find the point of contact using the given conditions. Question 7. Find points at which the tangent to the curve y equal to x cube minus 3x square minus 9x plus 7 is parallel to x-axis. Let us find dy by dx, which is the slope of the tangent to this curve at any general point x comma y. Derivative of x cube is 3x square minus 6x minus 9. And it is given in the question that the tangent is parallel to x-axis. So, slope of the tangent should be equal to 0. That is, dy by dx should be 0. We can divide the whole equation by 3. Let us factorize. Product should be minus 3, sum should be minus 2. Therefore, the factors are x minus 3 and x plus 1. We get x equal to 3 and x equal to minus 1. We have to find the points. We will find the corresponding y coordinates. If x is 3, y will be, we will use the curve equation to find the y coordinate. 3 cube minus 3 times 3 square minus 9 times 3 plus 7. 27 minus 27 minus 27 plus 7. The y coordinate is minus 20. Therefore, the point is 3 minus 20. If x is minus 1, we will use the curve equation to find the y coordinate. Minus 1 the whole cube, minus 3 times minus 1 the whole square, minus 9 times minus 1 plus 7. Minus 1, minus 3, plus 9, plus 7. The answer is 12. Therefore, the point of contact is -1, 12. The points are 3, -20 and -1, 12. We have 2 points on the curve at which the tangents are parallel to x-axis. Question 8. Find a point on the curve y equal to x minus 2 the whole square at which the tangent is parallel to the chord joining the points 2, 0 and 4, 4. Let this be the curve y equal to x minus 2 the whole square. 2, 0. Let us take 4, 4 here. This is the chord joining these 2 points. Now a tangent is drawn parallel to this chord and we have to find this point of contact. Since these 2 lines are parallel, their slopes must be equal. Let us find dy by dx, which is slope of the tangent. Power has to be differentiated first, keeping the base same, and then base has to be differentiated, which is 1 minus 0, 1. Now we will find the slope of the chord joining the given 2 points. If we know 2 points on a line, to find the slope, the formula is y2 minus y1 upon x2 minus x1. We will take this as x1 y1, this as x2 y2. We get 4 minus 0 upon 4 minus 2, which is 2. As the tangent is parallel to this chord, their slopes must be equal. Therefore, slope of the tangent and slope of the chord should be equated. X minus 2 is 1, therefore x is 3. X coordinate of the point of contact is 3. To find the y coordinate, let us use the curve equation. Y is x minus 2 the whole square, that is 3 minus 2 the whole square, 1. Therefore, the point of contact is 3, 1. Question 9. Find the point on the curve y equal to x cube minus 11x plus 5 at which the tangent is y equal to x minus 11. We will differentiate the curve equation and get dy by dx, which will be slope of the tangent. Derivative of x cube is 3 times x square minus 11 times derivative of x is 1 plus derivative of 5 is 0. Tangent equation is also given. We can get slope of the tangent by differentiation. Dy by dx is 1 minus 0, which is 1. And this is the tangent to the given curve. These 2 slopes must be equal. 3x square minus 11 is equal to 1. 3x square is 12. X square is 12 over 3, 4. So we get 2 answers for x, plus or minus 2. Since we are getting 2 points for one given tangent, we have to substitute in both the equations and check whether we are getting the same answers for y. If x is 2, we will calculate the y value. We can either substitute in the curve equation or in the tangent equation, but both should give us the same answer. Let us substitute in the curve equation. We get 2 cube minus 11 times 2, 22 plus 5. 8 plus 5, 13. 13 minus 22 is minus 9. Let us substitute in the tangent equation and check. Y is x is 2, 2 minus 11 minus 9. Both these equations are giving us the same answers for y. Therefore, the point is 2 minus 9. Let us check with the value x equal to minus 2. We will substitute in the curve equation. Minus 2 the whole cube is minus 8. Minus 11 times minus 2 is plus 22 and plus 5, which is 19. Let us plug in this value in the tangent equation. We get y equal to minus 2 minus 11, which is minus 13. These two y values are not the same. Therefore, x cannot be minus 2. Therefore, the required point is 2 minus 9. Question 10. Find the equation of all lines having slope minus 1 that are tangents to the curve y equal to 1 upon x minus 1, where x is not equal to 1. We will find the slope of the tangent dy by dx, and we will equate this dy by dx to minus 1. To find dy by dx, we can use quotient rule, or we may write the equation as x minus 1 whole power minus 1 and use chain rule. If we use chain rule, we get minus 1 times x minus 1 whole raised to minus 2, and we have to differentiate the base, which is 1, which is 1 upon x minus 1 the whole square. Now, slope of the tangent is given as minus 1, and dy by dx is also slope of the tangent. We will equate it to minus 1. Let us cross multiply. X minus 1 the whole square is plus 1. X minus 1 is plus or minus 1 by taking square root on both sides. We have two equations to solve. X minus 1 is plus 1, x minus 1 minus 1. Here we get the answer 2, and here we get the answer 0. Now we will find the y coordinate by using the curve equation. If x is equal to 2, y coordinate will be 1 upon 2 minus 1, which is 1. Therefore, the point is 2, 1. If x is 0, the y coordinate is 1 upon 0 minus 1, which is minus 1. Therefore, the point is 0, minus 1. We have to find the equation of the tangent. Equation of the tangent formula is y minus y0 equal to m times x minus x0, where x0, y0 is the point of contact and m is the slope of the tangent. We will write the first answer at 2, 1. This is x0, y0, and slope of the tangent is minus 1. It is given in the question. Y minus 1 is equal to minus 1 times x minus 2. Y minus 1 is minus x plus 2. Therefore, the equation of the tangent at 2, 1 is x plus y equal to 3. Now, the second answer, we will find the equation of the tangent at the second point, 0, minus 1. Now, this is our x0, y0, and slope of the tangent is the same, minus 1. Therefore, the equation is y minus of minus 1 equal to m is minus 1, x minus 0. Y plus 1 is minus x. Therefore, x plus y is minus 1. Question 11. Find the equation of all lines having slope 2 which are tangents to the curve y equal to 1 upon x minus 3, where x is not equal to 3. It is exactly of the same type as 10th question. Slope of the tangent is given as 2. We will write y as x minus 3 whole raised to minus 1. We will use chain rule to find dy by dx. Minus 1 into x minus 3 whole raised to minus 2 times the base has to be differentiated, which is 1 minus 0, 1, which is minus 1 upon x minus 3 the whole square. We can equate this slope to 2 because slope of the tangent is given as 2. By cross multiplication, we get x minus 3 the whole square equal to minus half. Not possible, because square of a number cannot be negative. Hence, tangent does not exist with a given slope. Question 12. Find the equations of all lines having slope 0 which are tangent to the curve y equal to 1 upon x square minus 2x plus 3. Here, slope of the tangent is given as 0. We will write y as x square minus 2x plus 3 whole power minus 1 and differentiate using chain rule, or we may use quotient rule and differentiate. So, using chain rule, dy by dx is using power rule first. minus 1 times x square minus 2x plus 3 whole raised to minus 2 times base has to be differentiated. Derivative of x square is 2x minus 2 times derivative of x is 1 and derivative of 3 is 0. We get minus 2 times x minus 1 divided by x square minus 2x plus 3 the whole square. Taken 2 out from this factor. Now we will equate this to 0 because slope of the tangent is given as 0. By cross multiplication, we get minus 2 times x minus 1 equal to 0. That is x minus 1 is 0, x is 1. Now by substituting the x coordinate in the curve equation, we can get the y coordinate. 1 upon 1 minus 2 plus 3, which is half. The point of contact is 1/2. Now we will write the equation of the tangent. The formula is y minus y0 equal to m times x minus x0, where x0, y0 is this point and slope is given as 0. That means the tangent will be parallel to x-axis. Since it is parallel to x-axis, the equation will be of the form y equal to y0. So directly we can use this formula also. Y minus y0 is half, m is 0, therefore the right hand side becomes 0. Multiplying the equation by 2, we get 2y minus 1 equal to 0. This is the equation of the tangent whose slope is 0 and it is parallel to x-axis. Question 13. Find points on the curve x square by 9 plus y square by 16 equal to 1 at which the tangents are first subdivision parallel to x-axis and the second subdivision parallel to y-axis. If the tangent is parallel to x-axis, we know that slope of the tangent should be 0. And if the tangent is parallel to y-axis, slope of the tangent is not defined. We will differentiate the curve equation to find the slope of the tangent. 1 by 9 is a constant, derivative of x square is 2x, plus 1 by 16 is a constant, derivative of y square is 2y times dy by dx, which is the differentiation of the base, equal to derivative of 1 is 0. 2 by 16 y dy by dx is minus 2x upon 9. Therefore, dy upon dx is minus x divided by 9 over y divided by 16. By writing the reciprocal of the denominator, we get 16x over 9y. This is the slope of the tangent. Let us do the first subdivision. It is given that the tangent is parallel to x-axis. So, slope of the tangent must be 0. By equating the slope of the tangent to 0, we get x coordinate as 0. Now we will find the y coordinate by substituting it in the curve equation. The curve is an ellipse here. 0 over 9 plus y square over 16 is 1. Y square is 16, therefore y is plus or minus 4. Therefore, the required points are 0 plus or minus 4. Now we will do the second part. Here the tangent is parallel to y-axis. We know that the slope is not defined. Slope of the tangent is minus 16x over 9y. This ratio is not defined when the denominator becomes 0. Therefore, we get y coordinate as 0. Now to find the corresponding x coordinate, we will use the given curve. X square over 9 plus 0 by 16 is 0 equal to 1. X square is 9. Therefore, x value is plus or minus 3. Here also we are getting 2 points of contact which are plus or minus 3 and 0. In this question, we have to find only the points of contact. We know the answer for this question before even solving it. We know that the given equation is an ellipse. A square is 16, b square is 9. So, a will be 4, b will be 3. On the y-axis 4 units, on the x-axis 3 units. If we draw tangents to this ellipse, which are parallel to x-axis, we get two tangents, one at 0, 4 and the other one at 0, -4. So, for the first subdivision, the answer is 0, plus or minus 4. Similarly, let us draw tangents parallel to y-axis. We can draw one tangent at 3, 0 parallel to y-axis and another tangent at -3, 0 which is parallel to y-axis. Therefore, the answer for the second subdivision is plus or minus 3, 0. Question 14. Find the equations of the tangent and normal to the given curves at the indicated points. First one, y is equal to x power 4 minus 6x cube plus 13x square minus 10x plus 5 at 0, 5. We will differentiate and get the slope of the tangent. Dy by dx is 4x cube minus 18x square plus 2 times 13 is 26x minus 10 times 1 plus 0. The point of contact is given, so we can find the slope of the tangent at that point 0, 5. We will substitute x value as 0, 0 minus 0 plus 0 minus 10. We get the slope as minus 10. Now we will write the equation of the tangent. The formula is y minus y0 equal to m times x minus x0. Y minus 5, slope is minus 10, x minus x coordinate of the point of contact is 0. Y minus 5 is minus 10x. Therefore, 10x plus y equal to 5 is the equation of the tangent. We have to find equation of the normal also. If slope of the tangent is minus 10, slope of the normal will be plus 1 upon 10. Change the sign and write the reciprocal. That is, using the result m1, m2 is minus 1. Now we will write equation of the normal, which is y minus y0 equal to, here we have to write slope of the normal, times x minus x0, y minus, the point of contact is 0, 5, y coordinate is 5, slope of the normal is 1 upon 10, x minus x0 is 0. Let us cross multiply. 10y minus 50 is x. Therefore, the answer is x minus 10y plus 50 equal to 0. Same way we have to do the other subdivisions. Second subdivision, the curve equation is y equal to x raised to 4 minus 6x cube plus 13x square minus 10x plus 5 and the point of contact is 1, 3. Let us differentiate and write dy by dx. 4x cube minus 18x square plus 26x minus 10. We will find the slope of the tangent at the given point of contact. So x has to be taken as 1. 4 times 1 minus 18 times 1 plus 26 into 1 minus 10. 30 minus 28, which is 2. This is slope of the tangent. Therefore, slope of the normal. Change the sign and write the reciprocal. That is, using the formula m1, m2 is minus 1. Let us write equation of the tangent formula. Y minus y0 equal to m times x minus x0, where m is the slope of the tangent. The point of contact is x0, y0 and slope of the tangent is 2. Y minus 3 is 2 times x minus 1. Therefore, y minus 3 is 2x minus 2. The equation becomes 2x minus y minus 2 plus 3 is plus 1 equal to 0. Now let us find equation of the normal. The formula is y minus y0 equal to minus 1 upon m times x minus x0, but you should not get confused which slope to take, 2 or minus half. So it is better to write inwards, slope of normal times x minus x0. Point of contact is the same. We get y minus 3. Slope of normal is written here, which is minus half, times x minus x0 is 1. Let us multiply the whole equation by 2. 2y minus 6 is minus x plus 1. Therefore, the equation of the normal is x plus 2y minus 7 equal to 0. Third subdivision, the curve is y equal to x cube at 1, 1. We will find dy by dx, which is 3x square, and we can find slope of the tangent at the given point of contact, 1, 1, which is 3. This is slope of the tangent. Slope of the normal will be, change the sign and write the reciprocal, because m1 into m2 is minus 1. We will write the equation of the tangent. Y minus y0 equal to m times x minus x0. x0, y0 is the point of contact and m is the slope of the tangent. So we get y minus 1 equal to, slope of the tangent is 3 and x0 is 1. Let us open the brackets, 3x minus 3. Therefore, equation of the tangent is 3x minus y minus 2 equal to 0. Now let us write the equation of the normal. Y minus y0 is equal to slope of normal times x minus x0. Or you may write minus 1 by m for slope of the normal. By mistake, you should not copy the wrong slope, so it is better to write in words. Point of contact is the same. Slope of the normal is minus 1 upon 1 by 3. X minus x0 is 1. We will multiply the whole equation by 3. Therefore, the equation is x plus 3y minus 4 equal to 0. Fourth subdivision. The curve equation is y equal to x square and the point of contact is 0, 0. Let us find dy by dx, which is 2x. Now we will find slope of the tangent at the given point, which is 0. Slope of the tangent is 0, that means tangent is parallel to x-axis. Therefore, normal will be parallel to y-axis. And equation of the tangent is y minus y0 equal to m times x minus x0, or directly we may write the equation as y equal to y0 because the tangent is parallel to x-axis. It will be of the form y equal to y0. Y minus 0, m is 0. Therefore, the answer is y equal to 0. That is x-axis itself. So, normal will be the y-axis because the point of contact is the origin. Through the origin, you have to draw a line perpendicular to x-axis, means it is going to be the y-axis. Now, let us write the equation of the normal. Formula is y minus y0 equal to slope of the normal into x minus x0. Slope of the tangent is 0. So, slope of the normal will be minus 1 upon 0, which is not defined. Y minus 0 equal to minus 1 upon 0 times x minus x0. So, if we cross multiply, we get x minus x0 equal to 0. x0 is 0. Therefore, the equation is x equal to 0, or directly we may write the answer as x equal to 0 because we know that the tangent is the x-axis at the origin. Therefore, normal will be y-axis through the origin. Fifth subdivision. The parametric equations are given. X is cos t and y is sin t at t equal to pi by 4. Let us differentiate with respect to t. Dx by dt is minus sin t and dy by dt is cos t. We will find dy by dx, which is dy by dt upon dx by dt. Dy by dt should be in the numerator, which is cos t, and denominator is minus sin t, which is minus cot t. T value is given, so dy by dx at t equal to pi by 4, which is minus cot pi by 4. The answer is minus 1, which is slope of the tangent. Therefore, slope of the normal will be, change the sign and write the reciprocal. Reciprocal of 1 is 1. Because of the result m1, m2 is minus 1. Let us write the equation of the tangent. Y minus y0 equal to slope of the tangent into x minus x0. Now, point of contact x0, y0 is not given in the question, but we can find x is cos t and t is pi by 4. Cos pi by 4 is 1 upon root 2. Similarly, let us find the y coordinate when t is pi by 4. Y is sin t, which is sin pi by 4, which is 1 by root 2. Therefore, the point of contact is 1 by root 2, 1 by root 2, which are x0, y0. Therefore, equation of the tangent is y minus 1 by root 2 equal to m is minus 1, which is slope of the tangent, and x minus 1 by root 2. This is minus x plus 1 by root 2. We get x plus y equal to 2 by root 2, that is 1 by root 2 plus 1 by root 2, which becomes root 2. Therefore, equation of the tangent is x plus y equal to root 2. Now, let us find equation of normal. The formula is y minus y0 equal to slope of normal times x minus x0. Point of contact is the same and slope of the normal is plus 1. Copy the correct normal and x0 point is 1 by root 2. Y minus 1 by root 2 is x minus 1 by root 2. They are getting cancelled. We get the equation x equal to y.